So in this video, we're going to take a look at an example of an applied example, where, in other words, where we use the normal distribution in real life. And a lot of times for these sorts of standardized tests, the normal distribution is used to be able to gauge, the specific benchmarks, etc. So let's say for some reason we have an instructor and they give an exam and they find the average grade of the exam to be 72 and the standard deviation of the exam is 7. The grades are known to be normally distributed. So we're going to construct the normal distribution and then we're going to find some probabilities or percents. All right, so let's start with the normal distribution construction. And this is something we did in the first video. So here's our normal distribution. And remember, dead in the middle is going to be 72 because that's the average grade. And then one standard deviation above, so this is mu, and mu plus sigma would be 79 because we would just take 72 plus 7. And then two standard deviations, mu plus 2 sigma. We're just going to add 79 and we're going to add 7 to that. And that's going to give us 86. So that's going to be our 79 plus 7. And then finally, mu plus 3 sigma. And that's going to be 86 plus 7. Right, and that's going to give us a 93. Right. And then we can do the exact same thing in the negative direction, which shouldn't be too difficult. Right, so let's just go ahead and write those out because, as you know, you can just keep subtracting 7 in this case each time. Right, so right here is going to be mu minus sigma, and that's going to be 65. And then over here, mu minus 2 sigma, that's going to be 58. And again, we just keep subtracting 7. So right here, minus 7, here, minus 7, and then minus 7 more is going to be mu minus 3 sigma, which is going to be 51. And I'll get rid of all this other stuff that we don't need. And remember, anything that's lower than 51 is going to be an outlier in this case. And then anything greater than 93 is going to be an outlier. Okay, so right here and right here are the outliers for this. Right, so now we can go ahead, now that we know what the distribution looks like, and we can start being able to compute some of the probabilities. And this one says, what percent of the class scored lower than a 66? So first of all, we're going to construct the distribution just to get an idea of what we should be looking for. So in the middle is 72. Notice right here is 65, so 66 is like right about here. So it's kind of close to 72. All right, so that might be a reason that we go through and construct this graph, is to get an idea of where our different values are going to fall. And it does say that what percent of the class scored lower than a 66. So in this case, this is the area that we're interested in. Remember, to find an area, just like we did in the previous video, we use this formula, z equals x minus mu over sigma. In this case, x is 66, mu is the mean, which is 72, sigma is the standard deviation, which is 7. We're going to throw that in our calculator. So parentheses 66 minus 72, close parentheses, divide 7, and we're going to get 0.857 negative or 0.86 negative. All right, so remember, round it to 2 decimal places, please. All right, so this is going to be approximately negative 0.8. I think we said 7. Let me just make sure. Negative 86. And then finally, we just go to the table. And our z table, we're going to go to the negative side. We're going to go to negative 8, so 0.8. And then we're going to go all the way over to 6, which I believe is right here. Let me verify that. So it looks like if we line that up in our crosshairs, negative 0.86 is 1948.9. So that's going to be 0.19489. And just to be specific, the question does say what percent of the class. All right, so that's going to be equal to 19.489%. All right, so again, we just use our Z table, and that's going to help us to be able to figure out what the probability or the percent is. Now for letter C, it's saying what percent of the class scored between 70 and 79. So letter B, C. So here's our distribution. Remember, in the middle is the mean, which is 72. 70 is just a little bit to the left. 79 is right here. In fact, 79 occurs on our graph. Right? Remember, 79 is this value, and 70 is pretty close to 72 anyway. All right, so it just makes sense that that's what we're looking for, and it's a between problem. And you might remember that to compute a between problem, we need to compute Z1, Z2. In the previous video, we did this. And then once we do that, we subtract the areas. Okay. That does say areas. It looks like it says UEAS. All right, maybe I can make that look like a real word. There we go. Still looks like not too good, but it is what it is. So let's compute Z1. Now, if you remember, I suggest using the bigger Z first, or the bigger X, excuse me. Right, so this is 72 minus 79, 9 minus 72 over 7. That just ends up being 1, because that's going to be 7 over 7, which is 1.00. And then we're going to convert that in a note. Right. I'm going to erase this just so that way we have enough room to subtract. All right, but I think everybody can see that that's just going to be 1. And I'm going to write that as 1.00, so that way we don't make a mistake converting. Z2 is not going to work out as nicely. So that's going to be 70 minus 72 over 7. And we're going to calculator that one. So that's going to be parentheses 70 minus 72 divided by 7. And negative 0.29, since it's 285, so negative 0.29. And now we're going to go into the table, and we're going to convert both of those. So in our table, negative 0.29, so here's negative 2, and then we go all the way over to 9. So that's 38591. So that's 0.38591. And then we're going to look up 1.00. So we're going to go all the way back up, or we're going to go down, excuse me. So we're going to do 1, and 1.00 is right here, 0.84134. So that's going to be 0.84134. And then remember, the last thing we do is we subtract. So that's going to be 84134 minus 3 something, 38591. So 38591, and that's going to give us 45543. So back, and that's going to be, after we subtract those, 0.45543, I think. Yeah, 45543. And then technically, because the question does ask for percent, we do have to convert it. So 45.543% is going to be our answer. One last example. And this one asks us, what's the percent of the class that scored higher than an 80? All right, so 80 is just a little bit more than 1 deviation above. All right, so it's going to happen right about there. So we draw our graph. Here's our graph. And again, the graph is just to make sure that we get the right answer. It makes sense. So maybe 80 is going to be right here. We have our mean of 72. And you might remember that it says what percent of the class scored higher than 80. Right? So higher means to the right. It's bigger. So right here is our area. All right. So if we got something like 95%, or 88%, or even 55%, we know we're wrong. We're probably looking like maybe 10, 15, 5%, 20%, something like that. All right, so a smaller percentage. Formula, same formula it's been the other 6 times. And so we're going to say that in this case, z is going to be 80 minus 72 divided by 7. I believe that's going to be 1.14, but let me go into the calculator and check that, because I think 1/7 is 0.14 something. So we're going to have 80 minus 72, and we're going to divide that by 7, and 1.1428, so it is indeed 1.14. Last thing we're going to do, we're going to look it up. So we go to 1.1, which is right here, and then we go to 4, 87286. So right here. So that means it's going to convert by the table to 0.87. I forgot already. 87286. All right, but that doesn't make any sense. Okay, so we look at that and we know that that's not 87%. Right? So how do we get the answer? Well, remember what 87.876 really is, or 0.87286, excuse me. That's this area, 87286. It's everything from the leftmost point of the curve all the way up to 80. All right, so what do we need? We need the complement of that. So the complement is 1 minus 0.87286. And I think that's going to be 12714. I'm going to put that in the calculator real quick just to verify my mental math. So 1 minus 0.87286, I think it was. And that's going to be 12714. 12714 is correct. And we wouldn't want to do all this work to get the answer, but not get the percentage, right? So that's not correct. We're going to erase that, and we're going to say that the percent is 12.714%. So just be careful as to what the instructor is asking for. If they ask for a percent, make sure you give percent. If it just says probability, you can give it as a percent or a decimal. If you're feeling froggy and want to put it as a fraction, you're welcome to do it that way too. All right. So 2 videos as to how to compute probabilities. One last video is we're going to go backwards, and given the probability, we're going to compute what this x value is, or the original raw data, if we ever needed that for some reason.